Power. Today we're going to do a small review on the final exam for 2412 Pre-Cal 2. Okay, let me start from the beginning. Okay, here we go. Okay, guys, most students, all students have to know the unit circle. Okay, I'm not going to go over in detail. I believe I did a PowerPoint on the unit circle on week 1, but I'm going to do a summary real quick on how to construct the unit circle. Okay. And again, you guys have to know this for upper level math courses such as Cal 1, Cal 2, Cal 3, differential equations, and I believe also engineering courses. Most of the instructors they don't let you use the handout in future courses, so it's wise for you to understand how to construct it and how to use it. Okay. Anyway, here's a unit circle, a copy of it, but here's a summary on how to construct the circle. Okay, I'm going to do it in 2 parts, and then at the end, we'll put them together. Okay, the first part, there's 3 parts that you have to find for each part. You have to find radians, degrees, and the point. Okay, so for the first part, we're going to cut the circle in 8 equal parts. Okay. Okay, there we go. Okay, so then here's my starting point. Okay, and it goes counterclockwise. So we're going to start with 0. And then for the first part, I'm going to divide everything. I'm going to count by pi over 4. So we start with 0, and then pi over 4, 2 pi over 4, 3 pi over 4, until we get to 8 pi over 4. Example, this is 0, that's pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5, 6, 7, 8 pi over 4, and then you simplify. Hey students, these here guys, for example, this comes from the unit circle, right? This is or from the coordinate grid. This point here is 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Okay, keep that in mind. So once you find the radian, you have to find the degrees. So the degrees, we start with 0 and we count by 45. So this will be 0, 45, 90. 90 plus 45 is 135, then 180. Then 225, 270. All we're doing is counting by 45. We add 45 to each here line here until we get to 360. Okay. Then comes the points. Every radian with a 4 on the denominator has a point of square root of 2, a square root of 2 over 2, square root of 2 over 2. So for example, this is pi over 4, so this will give us the square root of 2 over 2, square root of 2 over 2. This will give us 3 pi over 4, which will give us negative square root of 2 over 2 and square root of 2 over 2. So what's important about part 1, guys, is you have to make sure that the signs match the quadrants. Okay. And right now, after I do this slide, I'm going to show you how everything looks like. But again, if you missed the first week when I covered the unit circle, you can go back to that video. Okay, that way you can know exactly what I'm talking about here. Because if I will go over to the whole thing, this will take too long, and I won't cover material from other chapters. Okay, well, that covers part 1. Now part 2. Okay, we're going to cut the circle in 12 equal parts. Okay. Okay, first I need to find the radian, so we start with 0, and here's my starting point again. And we're going to count by pi over 6. So this will give us pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, all the way to 12 pi over 6, all the way to the starting point. And then we simplify. Okay, now, here guys, right, at pi over 6, everything, before I do that, let me go to the degrees, and then I get to the points. Then we're going to start with 0 and count by 30 degrees. So there will be 0, 30 degrees, 60 degrees, 90, 120, and so forth. Keep adding 30 until we get to 360. Okay, now, here's what I was talking about. Every radian with a 6 in the denominator, for example, everything with a 6, like pi over 6, the point will be square root of 3 over 2, 1/2. For example, this will be pi over 6, right? This will give us 2 pi over 6, but 2 pi over 6 simplifies to pi over 3. So every denominator with a 3 in the bottom, and the denominator, the point will be 1/2 the square root of 3 over 2. And make sure that the sides match the quadrant. Okay, now go to our next slide, and it's going to be the complete circle. See, there's your circle. I mean, what I was saying, that every point with a 6 on the bottom, right, as a denominator, this is my point. The square root of 3 over 2, 1/2. You see it's pi over 6, 5 pi over 6. You see same point, but the quadrant makes it negative and positive. Quadrant 3 at 7 pi over 6, you see both are negative. In quadrant 4, the 11 pi over 6, it'll be positive, negative. Same thing goes with a pi over 4, right? It'll be square root of 2 over 2. You see it, everything that's a 4 at the bottom, that's my point. But the quadrant tells you what signs are going to be for the x and for the y. And also for the pi over 3, same thing. Okay? And I was saying, recall when I mentioned earlier, that this will be 1, 0, 0, 1, negative 1, 0, and 0, negative 1. And again, if you need like a more detailed explanation on how to construct a circle, go back to week 1 when I covered the unit circle. Okay, and that's like in detail. Okay, so I mean, what I do in my exams, my students get to use they need to fill out the circle first, and that's the first part. And then after they turn in the circle, I let them use the handout, but I warn them that for the future courses, some instructors will not let them use the handout. I let them use the handout because when I was taking this course at Valle Verde, the instructor let us use a handout. That's why I do the same thing. Okay, but some instructors will not let you use the handout, so it's wise to memorize the circle. Okay, now this is number 1 now. Okay, again, I keep those in mind because now we're going to convert degrees to radians. What do we use to convert degrees to radians? The conversion is going to be pi and 180 degrees because those are equivalent. Okay, so this is a conversion to find radians. You're going to give you're going to state the given degrees. You multiply by pi radian over 180. That way the degrees will cancel and you're left with radians. Example. When we know that 45 degrees is equal to pi over 4. But how can I show it? Okay, by using the formula. So 45 degrees times pi radian over 180 will give us 45 degrees pi radian over 180. You see here, guys, the degrees will cancel. So I'm left with 45 pi over 180. And we simplify that, it's going to give us pi over 4. Okay. Same thing here with B, right? 60 degrees. 60 degrees is equal to pi over 3. And again, by using the conversion formula, here's how we show that 60 degrees is equal to pi over 3 in radian. So we multiply 60 degrees times pi radian over 180. You see here, guys, the zero with the degrees cancel. So I'm left with 6 pi over 18, which will give us pi over 3. Okay, but not every time you're gonna get like a perfect degrees that's in the circle, right? Because the circle, like I mentioned in week 1, is constructed by 2 special triangles, which is a 45, 90 degree triangle and a 30, 60, 90 degree triangle. So all those points and all those radians are based on those 2 triangles. And for example, 65 degrees, right, is not actually on the unit circle. The 65 degrees is, it is on the, between 0 to 360, but it's not a perfect triangle. So for that one, we cannot use, the handout. We have to actually figure it out by using, the formula. So it will give us 65 degrees pi radian over 180. Right? 65 over pi over 180 because the degrees cancel. 65 is 5 times 13, and 180 is 5 times 36. So the 5 cancel, so I'm left with 13 pi over 36. That's a conversion. Okay. Another one will be 200 degrees, right? So we multiply by the same formula. So it's going to give us 200 degrees pi radian over 180, right? Here, like the zeros cancel with a degree, so I'm left with 20 pi over 18. This will give us 2 times 10 will give us a 20. 2 times 9 will give us the 18. So the 2's cancel, so I'm left with 10 pi over 9. That's my result. Okay. Now we're going to go the other way for number 2. We're going to go from radian to degrees. Okay. And here, guys, what changes, you're going to stay here first. I give it degrees. You multiply by 180 over pi radian. This way, the pi's will cancel, and I'm left with degrees. For example, okay, we know that pi over 6 is 30 degrees, but here's how you show it. So I multiply pi over 6 times 180 degrees over pi radian. Right here, guys, the pi's are going to cancel. So 180 degrees divided by 6 is going to give us 30 degrees. In a similar fashion, pi over 4, right? Pi over 4 is equal to 45 degrees. But here's how we show it. We multiply by the conversion formula. Right? It's going to give us 180 degrees pi over 4 pi. The pi's cancel. So I'm left with 180 divided by 4 will give us 45 degrees. Okay. Now, again, but not every radian is a perfect is in a circle, right? Is a perfect triangle. For example, pi over 5 is not a perfect triangle that's in a circle. That's why to convert it, we have to use a formula. So it's going to give us 180 degrees over 180 degrees pi over 5 pi. The pi's cancel. So 180 divided by 5 will give us 36 degrees. And finally, for D part, convert pi over 12 to degrees. Right? So we multiply by the same formula. It's going to give us 180 degrees pi over 12. The pi's cancel. 180 degrees divided by 12 will give us 15 degrees. That's my answer. Okay. Okay, now this is number 3. Find the exact values of the 6 trigonometric functions of the angle theta. Okay, here, guys, they give us the two sides. So we're looking for the hypotenuse, which is equivalent to C according to the Pythagorean theorem. So A squared plus B squared equals to C squared. We plug in the values. And guys, this could be A or B, doesn't matter. But according to this trigonometry, guys, if this is big B, angle B, this must be little b. And vice versa, guys. But for now, it doesn't really matter. What matters is the hypotenuse is always C. Okay? So I'm going to plug in A. I put this as A, and this is B, or vice versa. It doesn't matter. So A squared plus C squared equals to C squared. This will give us 100 equals to C squared. We take the square root of both sides, so C equals 10. So I found my hypotenuse, which is my C. Now, right, according to the triangle, this is the adjacent side of this angle. This is the opposite side of the given angle. And this is your hypotenuse. So there are strict functions that you have to know, right? This is 8, 6, and 10. So the cosine is equal to adjacent over hypotenuse. The sine is opposite over hypotenuse. The tangent is opposite over adjacent. Okay, now, because the cosine and the secant are considered opposite reciprocals. So if we found the cosine, the secant is easy to find because all we do is flip them, right? So this is a reciprocal of adjacent over hypotenuse. The reciprocal will be hypotenuse over adjacent. Also with the sine will be the cosecant. They're opposite reciprocals. And also with the tangent and cotangent, they're also opposite reciprocals. So the cosine of theta is equal to adjacent over hypotenuse. So the adjacent will be 8 over 10. Right? Simplifies to 4/5. Right? When we find the cosine, we also find the secant. The secant, all we do is flip the numerator with the denominator. So it'll be 5 over 4. The sine of theta is equal to opposite, which will be 6 over 10, which will give us 3 over 5. So the cosecant will be 5 over 3. The tangent is opposite, which will be 6 over adjacent, which will be 8, 6 over 8, which will give us 3/4. So when we find the tangent, we also find the cotangent, which will be 4 over 3. That's how you solve a right triangle. Okay? Okay, now, here's number 4. Here's how we apply the rules for trigonometry in a word problem. Okay? It says, a guide wire runs from the ground to a cell tower. The wire is attached to the cell tower 150 feet above the ground. The angle formed between the wire and the ground is 43 degrees, as in this picture here. Okay? So this is my angle, 3 degrees. This is a wire attached to the top of the tower, right? There's probably like an antenna there. And this is 150 feet. Okay? Okay, now, here's what we're looking for. How long is a wire? So this is what we're looking for. This is wire. Is how long is this wire? So according to this angle, right? this is the opposite, this will be the adjacent, and this will be the hypotenuse. So we're looking for the hypotenuse for part A. For part B, it says how far from the base of the tower is the guide wire anchored to the ground. So we're looking for this length here. And this is considered the adjacent side. Okay? And here are my angles, right? Here are my formulas. So which ones are we going to use to find part A? How long is the wire? Right? We're given the angle and also the opposite side. So we have to use something with opposite, right? But it's going to be opposite over hypotenuse. So that means we have to use a sine. So for part A, will be the sine of theta is equal to opposite of hypotenuse. We plug in the values. So sine of 43 degrees is equal to 150 over hypotenuse. Hypotenuse is equal to 150 over sine of 43 degrees. Right? Use your calculator. So approximately, it will be about 219.9 feet. That's the length of the wire. Okay? Now, for part B, right, we're looking for the adjacent. Right? But now that we have also the hypotenuse, we can use anything, right? But let's keep it with the original. Because we can use the adjacent, right, of hypotenuse, which will be the cosine. But let's stick with what was given, right? So to find the adjacent with the angle and the opposite that was given, we're going to use the tangent, because the tangent is the opposite over adjacent. So let's plug everything in. Again, we're going to switch the adjacent side with a tangent of 43 degrees. Put in the calculator. It's going to give us about 160.9 feet. So that's the answer for part B. Okay, now, say that you want to use the hypotenuse, right? That you want to use the cosine. Since here, guys, this is rounded off, right? That's rounded off. So if you use that one, more likely you're going to get it wrong, because I believe on the homework, they want you to round off to one decimal place. So if we use this one, right, because this one is not exact, that's why it's not wise to use what we just found. Why? Because it's going to be a little bit off. That's why we stick with the original values that were given. Okay? Anyway, guys, that's how you work these type of problems, guys. Okay? Okay, now, area of a sector. Hey, guys, the area of a sector, guys, is this part here, guys. This is called a central angle, right? This is a radius, and there's a formula to find the area of a sector. Hey, guys, this is why you have to know how to convert. Because here, guys, the answer, right, is going to be, right, if it's in degrees, you have to convert it to radians. That's why problems 1 and 2, were crucial, because you have to know how to convert from degrees to radians. Okay, now, so, right, this is a problem here. It says a sprinkler on a golf course fairway sprays water over a distance of 70 feet and rotates through an angle of 120 degrees, as shown in the figure below. Right, so this is my 70 feet, and this is the angle of 120. So the sprinklers go like this, go back and forth, right? So what's the area that was being watered? So first, guys, we have to convert the degrees into radian. Okay? So again, right, this is a conversion. So 120 degrees times pi radian over 180. Right? The zeros cancel with a degree, so it's going to give us 2 pi over 3. But if you knew the unit circle, we know that 120 is a perfect degrees on the circle. We could have used that conversion also, guys. Okay? But then every time, this value, the degrees, is going to be on the circle that we can use. That we can just use a handout. Here, guys, we actually have to work it out. So it's better to work it out. So what's given, right? So I already got the radius. The radius is going to be 70, and the conversion of 120 degrees is 2 pi over 3. And we just plug everything in, use your calculator, and we get our answer. So the area approximately will be 5,131 square feet. That's how much water. The grass at the golf course was watered. Okay. Now number 6. It says evaluated trigonometric functions. Because here, guys, they give us 2 conditions, right? Condition 1 is that the tangent is going to be negative. Condition 2 is the cosine is positive. After that, guys, they want us to find the sine and the secant. Okay, so the solution here, guys, we have to find where the two conditions intersect, and also we need to find R. But first, we need to find when the two intersections intersect. That way, we know exactly where the solution is at and what quadrant. Okay, now the tangent, guys, is negative in quadrant when the signs are different. The sign, I mean the y and the x. So it'll be quadrant 2 and quadrant 4, right? You see here? When the signs are different, right? For example, sign is positive and negative, so it'll be quadrants 2 and quadrant 4. Because when the signs are the same, the tangent is positive. So in this condition, it's going to be quadrants 2 and 4. Now, where is the cosine positive? It's going to be positive in quadrant 1 and quadrant 4. So the intersection is quadrant 4, which means my answer is in quadrant 4, right? Which means that everything with a sine is negative, everything with a cosine is positive, everything with a tangent is negative. Okay? So the tangent of theta is equal to y over x, which means that my x is 4, right? Because it's positive, right? According to the condition, and my y is negative 5. Now we need to find r. So r is equal to the square root of x squared plus y squared. Let's plug in the values. It's going to give us 60 plus 25, so it's going to give us the square root of 41. So I find my r. Now the sine is y over r. My y is negative 5, and my r is 41, right? To simplify it, you multiply both sides. I mean not both sides. The numerator and denominator by square root of 41. So it's going to give us negative 5 square root of 41 over 41. But I believe if you plug it in like that and web aside, it's going to come out right. Okay, but it's always wise to actually try to simplify it all the way through. Now, the secant and the cosine, right, are opposite reciprocals. Remember from when we solved the triangle? So if the cosine is x over r, then my secant will be r over x. My r is square root of 41, and my x is equal to 4. So these are my two solutions, guys, what we're looking for. Okay? Now we're going to be graphing now, okay? But for number 7, they just want the 5 key points to sketch one period. Okay, we're not going to sketch here, guys, okay? They just want the 5 key points. So here, guys, we have to know what the A is, which is the amplitude, and the B. The B is to find the period. So the amplitude will be 1/4, and the B will be 1/6. So the period is 2 pi over B. So the period will be 2 pi over 1 pi over, 2 pi over 1/6. This will give us 2 pi times 6 over 1 will be 12 pi, which means the period to actually graph will be 12 pi. Okay, now to find the 5 key points, we divide the period by 4. Right, so it's going to be, my period is 12 pi, so it'll be 12 pi over 4 will give us 3 pi. So we start with 0, and then we keep adding 3 pi, so it'll be 3 pi, 6 pi, 9 pi, and 12 pi. Those are your 5 key points. Okay, but now, the sine starts at 0 or at 1. The sine always starts at 0. Okay, why is that? Because this is from the parent function of the sine. Just y equals to sine of x. This is a parent function, right? At 0 degrees from the inner circle, the sine is 0. At pi over 2, it'll be the amplitude. At pi, it's going to be 0. At 3 pi over 2 will be negative amplitude. At 2 pi will be 0. But these points here, the 0 pi over 2 pi, 3 pi over 2, and 2 pi, they come from the parent sine wave. Okay, but now all these points will be replaced by 0, 3 pi, 6 pi, 9 pi, and 12 pi. So, right, the first one will be 0, 0, right, 0, 0. My second point is going to be 3 pi and the amplitude. The amplitude is 1/4, so it'll be 3 pi 1/4. The third point is going to be 6 pi 0. My fourth point is going to be 9 pi and negative amplitude, so 9 pi negative 1/4. And my fifth point is going to be 12 pi 0. These are my 5 key points to actually graph one period of the sine wave. Okay. Now, let's do number 8. For number 8 is going to be horizontal translation. Okay. Here, guys, for the left endpoint, this is a formula, bx minus c equals 0. And for the right endpoint, it's going to be bx minus c equals 2 pi. Okay, I tell my students to don't worry about the translation until we find the 5 key points. So in this case, right, we need to find the 5 key points and then adjust the horizontal translation. So my A is going to be 1, right, because there's like a 1 there, and my B will be 4. So my period is 2 pi over B, so my period will be 2 pi over 4, which will be pi over 2. So we're going to count, we start from 0 and count by pi over 2. So 0, right? I don't know, no, my bad, guys. First of all, I mean, to get the 5 points, it's going to be the period over 4, which will be pi over 2 over 4, which will give us pi over 8. So I'm going to count by pi over 8. So we start with 0, pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8. Those are my points right there, right? Now let's simplify. It'll be 0, pi over 8, pi over 4, 3 pi over 8, and pi over 2, guys. Hey, guys, check this out. To make sure that these are right, the period, which will be pi over 2, will always be here. Once you divide the period by 4, the last point has to give you the period, which it does, which we see, so it's here, pi over 2. So I know this is correct. Okay, now, again, for the cosine, these are the 5 key points for the parent function of the cosine. It'll be 0, amplitude, pi over 2, 0, pi, negative amplitude, 3 pi over 2, 0, and 2 pi amplitude. So in this case, it's going to give me 0, right? 1, because the amplitude is 1. Then comes pi over 8, 0. Then pi over 4, negative 1, because negative amplitude. And then comes 3 pi over 8, 0. And then finally, pi over 2, amplitude, which will be 1, pi over 2, 1. Right, so this will be my 5 points without the horizontal translation. Okay, let me go to our next slide. And we just got the info that we just got from the previous slide, right? So these are my points here. Okay, now, let's find the formula to find the left endpoint and the right endpoint. For my left endpoint, right, we let 4x minus pi equal to 0, right? We add pi to both sides, so it's going to give us 4x equals to pi. We divide both sides by 4, x equals to pi over 4, so my left endpoint will be pi over 4. Now my right endpoint, you let write the inside there, 4x minus pi equals to 2 pi. We add pi to both sides, so 4x equals to 3 pi. Divide by 4, so x equals to 3 pi over 4. So my first point, instead of being 0, is going to be pi over 4, which means that I'm going to add pi over 4 to every x value on the point there. So I'm going to add 0 plus pi over 4, 1, which will give us pi over 4, 1. I'm going to add pi over 4 to pi over 8, right? If we add these, it's going to give us 3 pi over 8, 0. Then I'm going to add pi over 4 to pi over 4. Right? If you notice, the y value stays the same. So it's going to give us 2 pi over 4 will give us pi over 2, negative 1. We're going to add pi over 4 to 3 pi over 8. It's going to give us 5 pi over 8, 0. Then finally, I'm going to add pi over 4 to pi over 2, which will give us 3 pi over 4, 1. If you notice, guys, you see this is my left endpoint, the pi over 4, and this is my right endpoint, 3 pi over 4. So I know this is correct. Okay, now to graph it. Okay, to graph it, right? This is like the basic. I mean sideways, right? But I mean this is for the sideways. But what happened here is that every point got shifted to the right. You see, this is my my amplitude, -1 and 1, and this will be pi over 4. Pi over, this will be pi over 4, 3 pi over 8, pi over 2, 5 pi over 8, and 3 pi over 4. Guys, these points comes from here, right? Now the first point is going to be pi over 4, 1. My second point is going to be 3 pi over 8, 0. My third point will be pi over 2, -1. My fourth point is going to be 5 pi over 8, 0. And the last point is going to be 3 pi over 4, 1. You see, guys, so the cosine starts at the amplitude, but it got shifted pi over 4 units to the right. That's why every point moved pi over 4 units to the right. So to graph this graph, guys, this from here, guys, from here to here will be one period. And the graph continues forever and ever, all the way to the right and all the way to the left. But this is graphing one period. I believe most of the assignments on WebAssign, they want you to graph 2 periods. Okay? I didn't do 2 periods, guys, because I barely have room to do 1 period. That's why I only did 1. But for 2 periods, guys, it continues going like that, going to the left and also going to the right. Okay? Now comes number 9. It says find the exact values of the expression. Okay, now guys, it says the tangent of the arc cosine of 2 over 3. Hey guys, from the inside of the parentheses or brackets, you're gonna come up with a triangle, right? We know this is quadrant 1 because the arc cosine is from 0 to pi, right? And at pi, the cosine is negative, but in this case, it's positive, so it's quadrant 1, right? So that means that the sine is positive, cosine is positive, everything's positive. Now from here, guys, we form a triangle, right? So cosine is adjacent over hypotenuse, so this will give us the adjacent will be 2, and the hypotenuse will be 3. Since we're looking for the tangent, and the tangent is opposite or adjacent, we need to find for the opposite. Okay, so we use the Pythagorean theorem. So 2 squared plus b squared equals 3 squared. So 4 plus b squared equals 9. We subtract 4 from both sides. So b squared equals 5. So b is equal to the square root of 5. So I got my b, which is the opposite. Now the tangent, right, because we're looking for the tangent, is opposite over adjacent. My opposite is square root of 5, and my adjacent is 2. So it'll be the square root of 5 over 2. This is my result, guys. Okay? And again, from the inside of the brackets or the parentheses, that's where you solve the triangle. After you solve it, you look whatever we have here on the left, which is a tangent. If it was cotangent, right, then it will be adjacent over opposite and so forth like that, guys. So, but this is the most important part because from here we form a triangle and we solve the triangle. Okay. Now number 10, solve the right triangle. So what's given here, guys? What's given is A is 34.2 degrees. We also know that B, C is also, even though C is not given, we know because it's a right triangle, C is equal to 90 degrees. And that's what B is 19.4. So we're looking for angle B, little a, and little c. So for angle B, right, we know that the sum of the triangle has to be 180. So angle A plus angle B plus angle C must equal to 180. We already have the values for angle C and angle A, so let's plug them in. So B equals to 180 minus angle A minus angle C, right? We plug everything in, and B equals to 86.8. I found my B, angle B. Okay, now the angle and the adjacent are given. The angle and the adjacent are given. So what can we use, right? To find A, right? To find A, they give us the angle and the adjacent sides. To find A, it has to be opposite over adjacent, which would be my tangent. We plug everything in. We multiply both sides by 19.4. So 19.4 times tangent of 34.2 degrees is equal to A, right? Approximately will be 13.2. Okay, now A is 13.2. Now to find C, right, with what's given, it's going to be, right, adjacent, right, adjacent over hypotenuse. So it's got to be the cosine. Adjacent is 19.4. The angle is 34.2. Here, guys, we switch the cosine, the C and the cosine of 34.2. So 19.4 divided by cosine of 34.2 will give us something like 23.5, rounded off to the nearest 10. So C is equal to 23.5. So I solve my triangle. Okay. Now here's how we use what we just learned in a word problem. Okay. It says here, an observer in a lighthouse 350 feet above sea level observes two ships directly offshore. The angles of depression to the ships are 4 degrees and 6.5 degrees, as in the figure. Right. So what we're looking for is how far apart are the two ships. Okay. So solution, guys. Okay. So I need to form two triangles. The first triangle is going to be this one here. Right. We know that, okay, I'm going to take this triangle and put it here on the side. Okay, we know that this is 350, right? Because it has 350, this has to be also 350. And we're looking for this part here, guys, right? I mean, we're looking for this distance here, which would be the same thing as this distance here. So the angle is going to be 6.5 degrees. And let's call this distance 1. Okay. In a similar manner, right, we're going to solve, find the distance between the observer and the lighthouse to the second ship. So I guess for this one, okay, I'm going to get this triangle and put it outside here. Right, again, this is 350, but the angle, instead of being 6.5, will be 4 degrees. And this will be distance 2. Okay. So we are given the angle and the opposite side, right, looking for the adjacent. So we're going to use a tangent, because tangent is opposite over adjacent. Okay. So tangent of 6.5 equals 350 over d1. We switch the distance with the tangent by according to the ratio to the proportion rules, right? So we'll put in the calculators. It's going to give us about 3,071.91 feet. In a similar manner, we also do it for distance 2, right? So it's going to give us 5,005.23 feet. Okay, now we're looking for this distance here, guys, right? I mean, we're looking to see how far they're apart. So distance 3 is equal to distance 2 minus distance 1. So the distance that we're looking for, right, is going to be distance 2, which would be 5,005.23 minus 3,071.91. So the answer will be 1,133.3 feet. That's my distance that we're looking for. I mean, the distance between the two ships. Okay. Let's see here, number 12. Let me see. I think I have like 10 more to go, guys. Hopefully, I'll finish in time. It says find the 150th partial sum of the arithmetic sequence. So here, guys, what do we need? We need to find the first term and the 150th term, because we want the sum from the first term all the way to the 150th term. So we need to find the formula first, right? For the formula, we need a 1, which is 5, and we need the difference, which will be 11, right? The difference between all these will be 11, right? Because 16 minus 5 is 11. 27 minus 16 is 11, right? So we know it's going to be 11. So there's my formula. Plug the A1 there, and the difference, right? Distribute the 11. So it's going to give us 5 plus 11n minus 11 will give us 11n minus 6. So this is my formula, right? I already know what the first term is. Now I need to find the 150th term. So to find the 150th term, we plug in 150 for the n's. It's going to give us 1,644. Now we use the other formula for the sum, right? we got the first term and the last term. So for that, it's required for the formula, right? This is my first term. This is my 150th term. So it'll be 150 divided by 2 over 5 plus 1644. It's going to give us 75 times 1649. We multiply them out. So this is my solution, guys. It'll be 123,675. Okay, now write the expansion of the expression. Okay, here, guys, they want you to use perhaps Pascal's triangle. Hey, guys, for this section, you can use Pascal's triangle or you can use the combination formula. Okay, but let me show you both here. Hey, guys, this is the expansion, okay? But let me show you how we got that. Right, if you know, right, the color codes, the blue goes with this goes with a 5 combination 0. The pink goes with 5 combination 1. The green goes with 5 combination 2. The dark blue goes with 5 combination 3. And the purple goes with 5 combination 4. And the red goes with 5 combination 5. So you always start, right? You can put, right, this is like, from the formula, this is like A and B. So this will be 2x and negative y. You have noticed 2x, negative y, for each term. But you start with 5, and the bottom part here, because in the combination, always has to match this part here. You see, 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, and 5, 5. That's crucial to know, guys, okay? But anyway, guys, 5 combination 1, 5 combination 0 is going to equal to 1. 5 combination 1 is going to equal to 5. 5 combination 2 is equal to 10. 5 combination 3 is equal to 10. 5 combination 4 is equal to 5. And 5 combination 5 is equal to 1. Right? So 2x to the 5th power will give it 32x to the 5th. Negative y to the 0 will give us 1. 2x to the 4th will give us 16 to the 4th power. Negative y to the 1st power will give us negative y. 2x to the 3rd power will give us 8x cubed. Negative y squared will give us y squared, positive y squared. 2x squared will give us 4x squared. Negative y to the 3rd power will give us negative y to the 3rd power. And 2x to the 1st power will give us 2. And negative y to the 4th power will give us positive y to the 4th. And finally, 2x to the 0 will give us 1. And negative y to the 5th power stays as negative. Now we multiply them out. So this is my solution. Okay. But let me show you guys how we can get that, okay? I'm going to use something small, okay? So we start with y cubed, negative 3 to the 0, then y squared, negative 3 to the 1st power, and then y to the 1st power, negative 3 squared, and finally y0, negative 3 to the cube power. Okay, if you notice, right, now I need to put, we can use Pascal's triangle, or we can use a formula. Here, guys, I'm going to use a formula. This will be 3 combination 0, 3 combination 1, 3 combination 2, and 3 combination 3. Okay, now if you put that in the calculator, guys, it's going to give us 1. Y cubed, negative 3 to the 0 will give us 1. 3 combination 1 will give us 3. 3 combination 2 will give us 3. And 3 combination 3 will give us 1. Right? Then you multiply them out, and that's my solution. Okay, now guys, if you want a more explanation on this, guys, because I believe I didn't do the job that I wanted to do, guys, for this. I'm explaining how you do this. If you want, go to the PowerPoint or to the video that I did in regards to the section here. I believe this is section. Let me see. I believe it's chapter 9. I think. Yeah. No. I believe it's chapter 6. Okay. Okay. But anyway, let's move on. But again, hey guys, what's good to know here, guys, is that the 3 combination 0, guys, this number always matches the second term, right? Which is this term here. You see, the 0 matches the 0 here, the 1 matches the 1 here, the 2 matches the 2 here, and the 3 matches the 3 here. It's crucial, guys, for the next problem that we're going to do. Okay. Here it says find the 8th term and the expansion of 6x plus 2y to the 9th power. Because a lot of students that they don't know how to do it, I mean, the way I'm going to show you, they do the whole thing, which will be too long. It might take you for, I mean, a long time to do it. So here's, guys, how we're going to do it, right? Here's the formula. If you notice, right, this is my first term. This is my second term. And so forth, right? If you notice, the first term, the B portion will be 0. So it's always 1 less. You see, this is my second term. The B portion will be 1. Okay? Okay, so NR, right? So it's always 1 less. The R is always 1 less than the term. Right? So we're looking for the 8th term. So we're looking for the 8th term. It's going to be 9 combination 7. Right? Because this will always be 9 because that's the power that we're going to, right? And the B term, which is the R term, will always be 1 less. Okay, now, so it's going to give us 9, right, combination 7, right? It's always 1 less. Right, so my A is 6x and my B is 2y. Okay. So now, right, this is my term. So remember, guys, this number here, the bottom number always matches over here, guys. So that's going to be a 7 to the 7th power. And when you add these two, right, these two, when you add them, must equal to 9 because the power is 9. So 7 plus 2 will give us 9. That's why this will be squared. You see, guys, and that's how easy it is to find the term. Now, 9 combination 7 in the calculator is going to give us something like 36. 6x squared will give us 36x squared. And 2y to the 7th will give us something like 128y to the 7th. You multiply 36 times 128, and you got the coefficient, and this will be x squared, y to the 7th. So this is my solution. Guys, that's why it's very crucial to know that the R here, the R always matches the exponent for the B term. See, that's crucial to know. Okay. Now comes number 16. It says, find the number of 6-member committee that can be formed from a group of people consisting of 7 women and 8 men if the committee must have 4 women and 2 men. And again, guys, this is also going to be a combination problem. Okay. So here's my solution. There's 7 women, right? And we want to get, how many women do we need? 4. So it's going to be 7 combination 4. From the men, there's 8 men, and they must have only 2. Right? So it's going to be 8 combination 2. You put that in the formula, guys, or actually use the definition, right, to solve for it. But this you can actually be put in the calculator. 7 combination 4 will give us 35. 8 combination 2 will give us 28. You multiply them out. 35 times 28 will give us 980. So this is how many different groups can there be, or different committees. That's your answer. Okay, now number 17. Number 17 has 2 parts, A and B. It says a pair of dice are rolled. Find the probability of rolling a sum larger than 4. Okay. There's all the combinations of how a dice is rolled. It's going to be 36 because there's 36 horizontally and 6 horizontally and 6 vertically. So 6 times 6 is 36. My sample space will be 36. Okay. Now, so the probability of a sum larger than 4, it means has to be 5, right? 6, 7, or 8. So for the 5s, guys, right? We can here, right? This will be the sum of 5. We have 1, 2, 3, 4. So for the sum of 5 is going to be 4 of them. This here, guys, will give us the sum of 6, which will be 5. This will be the sum of 7, which will be 6. Sum of 8, which will be 5. Sum of 9, the sum will be 4. Sum of 10 is going to be 3. Sum of 11 is going to be 2. And sum of 12, will be 1. Right? We add them. So it'll be 30 over 36. The answer will be 5 over 6. You simplify. Now for B part, rolling a sum larger than 12. Right? My sample space is 236. But if you notice, guys, the sum of larger than 12, there's no way, there's nothing larger than 12 because the biggest number when you add the 2 die is 12. So it's going to be 0 over 36, but the chance will be 0. There's no way you can get a sum more than 12. The answer is 0. Okay. Now comes number 18, comes from chapter 10. It says find the standard form of the equation of the parabola with the given characteristics. The vertex is 6, 3, and the focus is 4, 3. Okay, there's two formulas, guys, that you can use, right? So in this case, that's my vertex and the focus. Which form is it? Is it vertical or horizontal? This is a vertical. I call this 1 to make it short, and horizontal will be 2. Which one is it? 1 or 2? How can we find out? Because this is your first step, guys, is to knowing which one we're going to use. Guys, if you notice here, guys, the H is here, guys, the H is repeat. And number 2, guys, the K is repeat. Here, guys, right here, the K is repeat. The K's are like the Y's, and the H's are like the X's. Right? K is repeat. So it's going to be number 2. Okay? Now, the vertex is 3, right? So from the vertex, according to the characteristics, right, my H is 6, and my K is 3. From the focus, right, is 4, 3. For the focus, I need to find my P. So it's going to be H plus P, right? According to the formula, H plus P equals H plus P, right? Will be 4 because my K, they repeat, so it'll be the same thing. So H plus P must be 4. My H is 6, so 6 plus P will be 4. Subtract 6 from both sides, so P equals -2. I found my P. Right? And guys, the main thing for the parabolas, guys, you have to find H, K, and P. Once you find those three values, all you do is plug them into the formula, right? And this is a formula, guys, that we're using, which will be y minus k squared equals to 4px minus h. We know that my k is 3, my p is -2, and my h is 6. So it's going to give us y minus 3 squared equals to 4 times -2 is -8. So it'll be y minus 3 squared equals to -8, parentheses, x minus 6. That's my solution. At times, guys, students ask me, Mr. Isasi, do I need to simplify it more? No, because this is the standard form of the equation of the parabola. That's the standard form. So that's where you leave it. Now, number 19 is going to be, for the ellipse. Right, but here, guys, we don't know if it's 1 or 2, guys, right? Because here, guys, we have to complete the square. We have to complete the square to find out which ellipse is present, 1 or 2. Okay? So now, what we do first here, guys, we're going to combine the x's and the y's. Now here, we're going to factor out the 4 because the y has to be a coefficient, the y squared has to have a coefficient of 1, and so does the x squared in order to complete the square. Here's where I'm going to complete the square, guys, okay? Because what goes here is half of 6. What's half of 6? 3. What's 3 squared is 9. What you do on the right side, on the left side, you do to the right side. Right? Here, guys, what's half of -2, right? What's half of -2 will be 1. -1, right? But when you square it, it's going to give us 1. Now, a mistake that students make is that they want to put a 1 here, like how we did over here with x. But here, guys, we don't put 1 because we have a 4 here. So we have to multiply 4 times 1 to balance the equation. 4 times 1 will give us 4, so the 4 goes there. Okay, now, guys, how can you go from here to the next step? Because you have to factor, but in reality, guys, you don't really have to factor. Here's how you do it. Okay, you're going to put only 1x. You're going to put the same sign, the plus. What's half of 6? 3, and then you square it. And then here for the y, guys, we've done the 4. We only put 1y. We keep the same sign. What's half of 2? 1. So this, the x squared plus 6x plus 9 is equivalent to x plus 3 squared. And 4 times y squared minus 2y plus 1 is equivalent to 4 times y minus 1 squared. So we have x plus 3 squared plus 4y minus 1 squared equals to 4. But according to the formula, guys, this has to be a 1. So we divide everything by 4. Right, so here, guys, it's going to give us, so here's going to give us, what's 4 divided by 4 is going to give us 1. There's my equation now, guys. So from there, guys, okay, which form is it? Horizontal or vertical? The largest number of the denominator, guys, A, which determines the type of ellipse. So this is going to be horizontal, right? The A determines, right? So this is going to be, if the A was over here under the Y, then it'll be vertical. But in this case, it's going to be horizontal. So I'm going to go to our next slide and carry this over. And that way we can find the center, vertices, and the foci, and then graph it. Okay, here we go. So we know that I need to find my H, K, A, B, and C. My H is -3. My K is 1. My A is 2. My B is 1. Okay, according with this information, we can find the center and the vertices. But to find the foci, I need to solve for C. So C squared is equal to A squared minus B squared, according to the formula, guys, for the ellipses. Plug in the values. So C squared is equal to 4 minus 1. C squared is equal to 3. So C is equal to square root of 3. I found my C. Now with that all given information, I can find my center. Center is HK, will be -3, 1. My vertices is going to be H plus or minus AK, which would be H, right, is going to be -3 plus or minus A, which is 2, 1. Will give us -3 minus 2, 1, and -3 plus 2, 1, which will give us -1, 1. These are my vertices. For the foci, it's going to be H plus or minus CK. So it's going to give us H will be -3 minus the square plus or minus square root of 3, 1, which would be -3 minus the square root of 3, 1, comma 1, and -3 plus the square root of 3, comma 1. These are my vertices. I mean my foci. The center, my vertices, and my foci. Now to graph it. Right, to graph it, right, this really means that it's going to be horizontal, right? Because, let me check this out, guys. To graph it, you can get these points by here, guys, all right? So my center will be -3, 3, -3, 1, right? That's my center. The A is going to be 2. That means that the A, we're going to go 2 to the right and 2 to the left. And the B is 1, so we're going to go up 1 and down 1. Then all you do is matching, guys. That's how you can graph it that way, guys. But this is the foci. -3 minus square root of 3 is equal to an irrational number, guys. It's going to be something with a decimal. There it is for the negative, and this is for the positive. But the easier way to graph it, guys, right? You go to the center. The A moves to the left because it's horizontal. It moves 2 to the right, 2 to the left, and the B tells you the minor axis, which would be 1 up and 1 down. Anyway, that's your graph. Number 20. Okay, I know it's already 12, guys, but I think I have two more to go. Number 20. Find the standard form of the equation of the hyperbola with the vertices 0, 2 and 4, 2, and the foci -1, 2 and 5, 2. Okay, solution. These are my vertices, right? These are my foci. So, which form is it? 1 horizontal or 2 vertical? There's my horizontal, and there's my vertical number 2. Because if you notice, because here, guys, the A and the B stay the same. And it's going to be minus, right? What switches and what tells you what it is if the x squared is positive, it's going to be horizontal. If the y squared is negative, it's positive, it's going to be vertical. So whatever is positive, guys, determines the axis. Okay, now, but here, guys, with the given characteristics, here, guys, all the k's repeat. Right? The y values repeat, so my case repeats, so it's going to be like number 1. Okay? Now, I need to find H, K, A, B, and C. The center is the midpoint of the foci or the vertices. Right? So I'm going to stick to the vertices. It's going to be 0, 2, and 4, 2, right? What's the midpoint between 0, 2, and 4, 2? The answer will be 2, 2. So I found my H, I found my K, 2 and 2. Now, right, with the vertices, I can also find my A, right? I can find my A for the vertices. So here, guys, right, it's going to be H minus A equals 0 because that's the lowest point. If the lowest number, right, is going to be the minus, and the positive number is going to be the plus. Here, guys, you don't have to do both. You can only do one. But here, guys, I'm just showing you both just so you know that we get the same answer. So what's the value for A? What's the value for H? The H is going to be 2. So it'll be 2 minus a equals 0, or 2 plus a equals 4. Guys, if you notice, guys, you see here's where we get the same answer. On the left side, right, if we add a to both sides, it's going to give us 2 equals 2a. On the right side, if we subtract 2 from both sides, it's going to give us 2. You see, we get the same answer, so my a is 2. In a similar fashion, for the foci, it's going to be to solve my c. The foci will be h plus or minus c equals k. We know that this is my lowest number, and this is my highest number. So for this one's going to be subtraction. For that one's going to be addition. Right? So it's going to be 2 minus c equals -1, or 2 plus c equals 5. I'm going to stick to the 2 plus c equals 5. We subtract 2 from both sides, so a equals 3. I mean c equals 3. I'll find my c. Now how do we solve for b? C squared equals to a squared plus b squared. So b squared equals to c squared minus a squared. Plug everything in. B squared equals to 9 minus 4. B squared equals to 5. B equals to the square root of 5. Okay. Now they want us to find the standard form of the equation, right? So this is the formula that we're going to be using. Plug in the values for h, plug in the values for k, plug in the values for a and for b, and we got our equation. H is 2, y is 2, a is 2, and b is square root of 5. So it'll be parentheses x minus 2 squared divided by 4 minus parentheses y minus 2 squared divided by 5 equals 1. That's my standard form of the hyperbola. Okay. But I have 2 more to go, and that's it. It says convert the polar point -2 7 pi over 6 to rectangular. Okay, so solution. To go from rectangular, which will be r theta, to xy, from polar to rectangular, here's what we need to know. X equals to r cosine theta, and y equals to r sine theta. So my r is -2, and my theta is 7 pi over 6. Okay, now, hey guys, what's 7 pi over 6? Again, guys, this is crucial to know the circle. 7 pi over 6, the point is negative square root of 3 over 2, -1/2. This is my cosine of 7 pi over 6, and this is my sine of 7 pi over 6. So plug everything in. My r is -2, and my theta is 7 pi over 6. So the cosine of 7 pi over 6 will give us negative square root of 3 over 2. Right? The negatives cancel with the 2, so the answer will be x equals to square root of 3. So for the y, right, y equals to -2 sine of 7 pi over 6. The sine of 7 pi over 6 is equal to -1/2. This will result in 1. So there's my answer, guys. There's my x and there's my y. The point will be the square root of 3, 1. Now this is the last one, guys. Now we're going to go the other way. The was rectangular, we want polar. Okay. Here, guys, you need to know what quadrant the point is on. Also, you need to know the r and the theta. Find r and theta. Okay, from rectangular to polar, right? This is to find r. R equals to the square root of x squared plus y squared, and this is to find theta. Theta is equal to the arctangent of y over x. Once we know the quadrant, right? This is quadrant 2. We know we need to add pi to quadrant 2. And why, guys? Because the arctangent is from negative pi over 2 to pi over 2, which is quadrant 4 to quadrant 1. So if it's in quadrant 4, it's going to give us a negative solution, right? Negative angle. So we have to add pi to go to quadrant 2. Okay, now. So here we go, guys. So r equals to -1 squared plus the square root of 3 squared. So it's going to give us the square root of 4. So r is equal to 2. I got my r. My theta is equal to y over x, which would be the square root of 3 over -1. Now, if you put that in the calculator, guys, it's going to give you negative pi over 3. If you put that in the calculator in the Casio, right? But we said, right, since this is quadrant 4, we want to go to quadrant 2, so I need to add pi to the arctangent of theta, which will give us 2 pi over 3. I found my r, I found my theta, so that's my solution, guys. 2 pi over 3. And I believe that's it for this presentation. I know I went like 7 minutes over, but I believe it was crucial to finish it off because this way you guys have more information to that will lead to the final exam. Okay, let me go back to the host. So they can.
Thank you very much, Mr. Sassi. And if you have any questions, just go ahead and ask them right now. Remember that this is your review for your final exam next week, so might as well go ahead and take advantage of Mr. Sassi. Mr. Sassi, you're available for questions also individually, right?
Yes, sir.
Okay, so if you would be so kind, Mr. Sassi, to provide your email in the chat. That way, Yesenia can contact you if she has any questions later on.
Of course.
Okay, Yesenia, do you have any questions right now?
There you go.
Okay, so if you don't have any questions, make sure that you provide your information to the facilitators, and that concludes our presentations for the semester. Mr. Isasi, it has been a pleasure working with you as always. This will be my last participation in the Happy Math Hour. And so next semester we will have some new people from prep doing this. But Alberto, thank you for everything. I mean, you are a wonderful, wonderful instructor.
Thank you, my friend. That means a lot to me. Thank you very much. Thank you.
All right, and Yesenia, you have a wonderful weekend. Remember, if you have any questions, reach out to Mr. Isasi. He's very helpful. He also conducts the Sunday numbers. Okay, so anytime you have something, a question like that, make sure to reach out. He's one of the good ones. Okay, so thank you very much. You all have a great weekend, and we'll be signing off.